Well, hello guys, here Mr. G with another video for the grade 12. This time we're going to be answering the last question of the mid-year diagnostic exam done in 2023 in the Northern Cape. This question is about acid and bases, and there is a couple of videos I made on acid and bases that can also help you with the answer for this one. Ethanoic acid is a weak acid. It reacts with water according to the following balance equation. And then you have the balance equation there. Define the term weak acid. So what is a weak acid? A weak acid is an acid that ionizes incompletely, and that is very important. It ionizes incompletely in water to form a low concentration of H3O plus ion. That is a weak acid. Now, please be careful. Don't confuse weak acid with dilute acid. The dilute acid is when there is little particle per unit volume of a solution. Okay, now there is a video on that one. I can try to leave the link for that one. Now question 7.2, refer to the equation above to write down a conjugate acid base pair, the conjugate or one acid base pair. Now let's start by identifying the family. The CH-COOH family will be the substance there. Now when you go from a reactants to product here like this, you can see that this H is gone, so therefore this one is an acid and this one will be the conjugate base. Very simple. They say only one, but let's identify the other one. Now the other family is the H2O and the H3O plus, and you can see as you go from reactants to product that you did have only 2 hydrogen, but now you have 3. So what is water going to be? Water is going to be the base, and then the H3O plus is going to be the conjugate acid. It's quite simple, guys. It's quite simple. So that is question 7.2. The answer for 7.2 is there in the equation. Milk of magnesia has been used over the ages to relieve stomach ailments caused by excess stomach acid. The active ingredient of milk of magnesium is magnesium hydroxide, and you have the magnesium hydroxide. This one is a base. Now, question 7.3.1, what mass of magnesium hydroxide must be dissolved in distilled water to prepare 500 cubic centimeter of magnesium hydroxide solution with a concentration of 0.2 mole per cubic decimeter? It's very simple calculation. Okay, so what we have there, we have the volume in which we are going to prepare. The volume of this solution is going to be equal to 500 cubic centimeter, but you cannot work with cubic centimeter, so we are going to convert to decimeter. Remember to do it by dividing by 1000, so let's do it here, and this is equal to 0.5 cubic decimeter. I just convert to decimeter cubic. What else do I have? I have the concentration here. It's given to us. Concentration is equal to 0.2 mole per decimeter cubic. And then I'm looking for the mass of the magnesium hydroxide. That is the question mark. So if we go to the formulas, you can see that there are two formulas in which concentration is involved, and one of them have mass, which is this one here. So we have everything but the molar mass, which we are going to calculate as one. So that is the formula we are going to use. Please go to the formulas, guys. It is there. So 7.3.1, let's write the data here. Concentration is equal to 0.2 mole per cubic decimeter. Volume is equal to 0.5 after converting decimeter cubic. And then we're looking for mass. And then the formula we're going to use is going to be concentration equal to mass divided by molar mass multiplied by volume. So the only thing we don't have is the molar mass. And let's quickly do that calculation for you also to see how it is done. It's very simple. We are working with magnesium hydroxide, which is MgOH bracket 2. So we look in the molar mass of magnesium hydroxide. So we have to go to the periodic table, guys, which is here is the answer for all the other questions. The periodic table is right here. We're looking for magnesium. There is the mass of magnesium on this side, guys. There's magnesium. We're looking for oxygen. There is 16 for oxygen. And we're looking for hydrogen. There is the 1 for hydrogen. So all you have to go to do is to go to the periodic table. It's quite simple. So let's go there quickly and then calculate the molar mass of magnesium here. Hydroxide, magnesium hydroxide. So molar mass is equal to magnesium, which is going to be 24 plus. Now this 2 is out of the bracket, so it's a 2, and I'm going to open bracket. 16 for oxygen plus 1 for hydrogen, and that will give me the molar mass, which is 58 grams per mole. There we go. Now this number must be substituted in that formula there, so we can actually do everything now. The substitute, we have 0.2 for concentration equal to mass divided by the product of 58, we did just calculate, multiplied by the volume, which is 0.5. And when you solve this one, the mass is equal to 5.8 grams. That is the mass that they are asking for. It's very simple calculation. The question 7.3.2, determine the concentration of OH ion. Assume 100% dissociation of magnesium hydroxide or K in water. And this is very good question because you needed some time for the pH. So this one is question 7.3.2. Okay, now what is going to happen here? Remember, the magnesium hydroxide OH is going to dissociate in water. Now that one, when dissociates in water, it's going to be broken into ions, which are magnesium 2 plus OH minus. You have to balance, so you can see that this 2OH, so I'm going to write the 2OH here. And then they're asking you for the concentration of the OH. That is the question mark. What is the concentration of the OH? Guys, all we're going to do is to use the ratio, and this is very important. The ratio of magnesium hydroxide OH to OH minus. You can see the ratio is 1:2. It means that the certain concentration of this one will give you double the concentration of ions in that solution. So if the concentration here was given to us as 0.2, so the concentration here was 0.2 mole per decimeter cubic. Let's write the unit, 0.2 mole per cubic decimeters. What will be the concentration of ions in that specific solution? And then you do cross product, guys. Very simple. In this case it's 2:1, so it's very, very simple. So you will get, when you do the cross product, that X is equal to 2 multiplied by 0.2. Guys, the concentration of the OH in this solution, concentration of OH minus in this solution, is double the other one, which is, in other words, 0.4 mole per cubic decimeters. Very simple. That is the answer. This one is important because sometimes you want to need it for the calculation of the pH, which is an actual fact. The next question, let's say the pH of any medication safe for human consumption must lie between 4 and 9. Perform calculation to show whether the magnesium hydroxide is safe for consumption. So all we have to do is to calculate the pH. Now, how do you calculate pH? pH is equal to, this one is question 7.3.3. pH is equal to minus log concentration of H3O plus. Amazing. Now we don't have here the H3O plus, we only have OH minus, but not to worry. We're going to go to the table of formulas once more. Note, there is the KW here. There is the KW there. We are going to be using just now. All right. Now with this KW, we're going to do it right here. The KW is going to be equal to the concentration of H3O plus multiplied by the concentration of OH minus, and all that is going to be equal to 1 times 10 to the minus 14. That is what we are going to use. We do have the concentration of OH and we need the concentration of H3O plus. We need that one. So we have to substitute, guys. It's very simple. So let's do that one real fast. Then let's take all this one with us to the answer of the equation there. And here we are with what we have. So if we do that and we substitute the concentration of OH, note this is the concentration of OH that was calculated in the previous question. This one is the concentration of the OH that was calculated previously. So saying that, let's go here and say concentration of H3O plus multiplied by the concentration of OH minus, which is 0.4. 0.4 is equal to 1 times 10 to the minus 14. So the concentration of H3O plus is equal to 1 times 10 to the minus 14 divided by 0.4. Alright? And when you go there, you get that the concentration of H3O plus is going to be equal to 2.5 times 10 to the minus 14. Okay? This is mole per decimeter cubic. Let's fix that one. Mole per cubic decimeters. And now, guys, you are going to substitute that one on the pH, which is the question right there as you can see it. Okay? So let's do that calculation real fast here. pH is equal to minus log of the concentration of the H3O plus, which is 2.5 times 10 to the minus 14, and then the pH is going to be equal to 13.6. That is the pH of the substance. Now all we have to go is go to the question. It's 13.6. Let's see the question. I went too far. The question is right here. The question is right here. The pH that is safe is between 4 and 9. So the pH of this, the pH is equal to 13.6. Therefore, not safe for consumption. There we go, and that is the answer of the question. It's a very good question. Question 7.4, which is the last question of this question 7, and it's going to be the last little sub question of the whole question paper set. The learners perform a titration of sulfuric acid against the magnesium hydroxide they have prepared. Magnesium hydroxide, we already have the concentration. The learners found that 25 cubic centimeter of the magnesium hydroxide of concentration 0.2 mole per decimeter cubic, that is the one we calculate, guys, was needed to fully neutralize an unknown volume of sulfuric acid with a concentration of 0.1 mole per cubic decimeter. The balance equation is, and we have here the magnesium hydroxide, which is the base, and we have the sulfuric acid, which is the acid. Alright, that one is known, guys. So we need to know that the ratios are 1:1. We need it for titration. Determine the volume of sulfuric acid. Now, we are going to use titration. So let's see what we have. Let's write here data for this specific question. We have the concentration of the base, which is 0.2 mole per cubic decimeter. We have the volume that was using of the base, which is 25, that is 25 cubic centimeters. And note, remember I told you previously in other videos that for titration you do not have to convert if you're going to use the titration formula. Be careful. only if you're using the titration formula. Okay, so the ratios are for the base, NB is going to be equal to 1. And we're going now for the acid. What we have for the acid, we have the concentration of the acid. Concentration of the acid is equal to 0,1 mole per cubic decimeter. Volume of the acid is been looking for, that is the question mark, and Na is equal to 1. We're going to look for the formula of titration, which is right here listening to us. There it is, the formula for titration. Remember, now for this formula you don't have to convert the volume, but I'm going to use that formula. There's other ways of solving this question. You don't have to use that formula if you don't want to. However, why you wouldn't use it if it's very easy? VA CA divided by VB and CV, fix that one there, CB is equal to NA divided by NB. And we have everything. All we have to do is to substitute. For the acid, we're looking for the volume of the acid. The concentration is 0,1 divided by everything we have for the base, which is volume is 25. Do not convert, you don't have to. Multiply by 0,2 is equal to 1 divided by 1. Remember I said you don't have to, but if you want to convert, if you think you're going to be safer by converting, then you're welcome to do it. You're welcome to do it, okay? So now here, guys, this is just simple method. Now, when you solve, VA is equal to 25 multiplied by 0,2 divided by 0,1. And the volume of the acid, when you do that very simple calculation, is going to be equal to 50 cubic centimeters. And this is the final answer of this amazing question paper to practice for June. And please note, this is not only for June, but is a very good question paper as well for September and end of the year. For September and end of the year, all we have to do is to add a question or two, and then we're sorted. But all these questions here are applicable for September and November question paper, which are the most important ones. But thank you for watching. Thumb up, subscribe for the channel. I'll see you next time with new work. Mr. G here.